There's something undeniably magnetic about the mysteries of the universe, the way they tug at our curiosity, whispering questions we can't quite answer. Look up at the night sky and you're not just seeing stars, you're staring into an endless cosmic puzzle, one where every galaxy holds secrets older than time itself. And among these celestial enigmas, few are as intriguing as NGC 4889. This colossal galaxy, hidden within the Coma cluster, isn't just another speck of light in the void. It's a realm of the unexplained, a place where the laws of physics seem to twist and warp in ways that defy logic. From black holes that shouldn't exist to stars vanishing without a trace, NGC 4889 is a stage for phenomena so strange they challenge everything we think we know about the cosmos. Imagine a galaxy so vast it could swallow our Milky Way whole, yet so mysterious that even our most advanced telescopes struggle to peel back its layers. NGC 4889 isn't just big, it's a cosmic hall of mirrors where light bends, time distorts, and the very fabric of space seems to unravel. Scientists have spent decades studying this giant, only to uncover more questions than answers. What's lurking in its core? Why do some of its stars pulse with rhythms we've never seen before? And what could explain the eerie, ghostly structures drifting through its depths like celestial phantoms? These aren't just curiosities, they're clues to some of the universe's greatest riddles, waiting to be deciphered. Today, we're diving deep into the heart of NGC 4889 to uncover 30 of its most baffling phenomena. Each one is a story, a cosmic oddity that pushes the boundaries of our understanding. Some will leave you in awe, others might send a chill down your spine. But all of them will remind you just how little we truly know about the universe we call home. So settle in, because this journey isn't just about observing the unknown, it's about feeling that thrill of discovery, that moment when the cosmos reveals just how wonderfully strange it can be. Ready to explore the unexplainable? Let's begin. The first mystery in NGC 4889 might just be its greatest cosmic disappearing act, the case of the missing supermassive black hole. In a galaxy this enormous, scientists expected to find a gravitational titan at its heart, a black hole so massive it could weigh in at billions of times the mass of our Sun. That's how these cosmic giants usually work. But when researchers pointed their telescopes toward the core of NGC 4889, they found nothing. Just an eerie silence where a monster should have been. So where did it go? One theory suggests a violent event called gravitational recoil, a cosmic slingshot effect where two merging black holes collide with such force that the resulting kick sends the surviving black hole hurtling out of the galaxy entirely. Picture two titans locked in a dance of destruction, their final clash propelling the winner into the void. It's a dramatic exit, but not impossible. The energy released in such an event would be unimaginable, rippling through space-time itself. Then there's the far more speculative idea: could something or someone have moved it? Before you dismiss it as science fiction, consider this. Advanced civilizations might harness black holes for energy or even as cosmic engines. While there's zero proof of alien intervention, the sheer strangeness of this absence forces us to ask wilder questions. After all, nature tends to follow patterns, and NGC 4889 is breaking every rule. What makes this even more puzzling is that the galaxy shows signs of violent past activity. Jets of radiation and twisted magnetic fields hinting at a black hole's former presence. It's like walking into a room where the furniture's been tossed around, but the culprit's vanished without a trace. Did it leave behind clues we're just not seeing? Or is this black hole lurking in the shadows, disguised in a way we don't yet understand? One thing's certain. This phantom at the heart of NGC 4889 challenges our most basic assumptions about how galaxies live and die. And until we solve this riddle, it remains one of the universe's most tantalizing ghost stories. But if the missing black hole left NGC 4889 feeling like an empty stage, the next phenomenon turns it into a cosmic concert hall, one playing a ghostly melody on repeat. Deep within this galaxy, astronomers have detected eerie radio bursts pulsing with such precise regularity, they defy simple explanation. These aren't the chaotic screeches of colliding stars or the random static of interstellar gas. These signals arrive like clockwork, each burst separated by intervals so exact they almost feel engineered. At first glance, the culprit could be a pulsar, a rapidly spinning neutron star that beams radiation like a lighthouse. But there's a problem. Pulsars slow down over time, their rhythm gradually decaying as they lose energy. These signals, though, they've kept perfect time for years with no drift, no variation. It's as if something is correcting the beat, maintaining a tempo untouched by the universe's usual chaos. That level of precision isn't just rare, it's unprecedented in natural cosmic phenomena. Then there's the frequency pattern itself. Most pulsars emit across a broad spectrum, but these bursts are oddly narrow, almost like a finely tuned radio station. Some researchers have even noted eerie similarities to signals once theorized as potential technosignatures, hypothetical markers of advanced civilizations. Of course, the scientific community is quick to caution against jumping to extraterrestrial conclusions. But when nature refuses to follow its own rules, even the most skeptical minds start whispering, what if? One compelling theory suggests an exotic type of magnetar, a neutron star with a magnetic field so intense it could warp the very space around it, creating stability in ways we don't yet understand. Another proposes a never-before-seen interaction between dark matter and stellar remnants, a cosmic feedback loop locking the bursts into their unnatural rhythm. But perhaps the most tantalizing idea is that we're seeing the aftermath of an ancient alien megastructure, a beacon or energy relay left behind by some long-vanished intelligence. After all, the universe is 13.8 billion years old. If other civilizations rose and fell before Earth even formed, wouldn't their artifacts still linger, humming quietly in the dark? What makes these ghostly echoes so unsettling isn't just their precision, it's their persistence. While other cosmic signals fade or flicker, these continue unabated, a metronome ticking across the eons. Whether natural or something beyond our current understanding, one thing's clear: NGC 4889 isn't just hiding secrets, it's broadcasting them. And if we learn to listen closely enough, we might just decipher a message written in the language of the stars themselves. Deep in the swirling arms of NGC 4889, astronomers have witnessed something that shouldn't be possible: entire star clusters disappearing without a trace. These aren't just a few stars fading into the background. We're talking about massive groups, hundreds or even thousands of stars strong, vanishing as if plucked from existence by an unseen hand. At first, researchers thought it might be an error in observation, a glitch in the data. But repeated studies confirmed the impossible. These clusters were there one moment and gone the next, leaving behind only ghostly afterimages in the galaxy's light. One leading theory points to the invisible puppeteer of the cosmos, dark matter. We know it's there, weaving its gravitational web through galaxies, but in NGC 4889, it might be behaving in ways we've never seen. Imagine dark matter forming dense, unstable knots, regions where its pull becomes so intense that it shreds star clusters apart in a cosmic tug of war. Stars wouldn't just fade, they'd be flung into the void or swallowed by the galaxy's hidden gravitational tides. It's a violent process, but one that could explain why these clusters vanish without the usual fireworks of supernovas or collisions. Then there's the idea of rapid stellar migration, a phenomenon where stars are yanked from their orbits and hurled toward the galaxy's center at breathtaking speeds. In most galaxies, this process takes millions of years, but NGC 4889's immense gravity could be accelerating it to breakneck pace. Picture a cosmic river, its current so strong that star clusters are torn apart in the flow, their stars scattered like leaves in a storm. This would leave no debris, no wreckage, just empty space where a vibrant community of stars once thrived. But the most unsettling possibility, these clusters might not have vanished at all. Instead, they could be hiding in plain sight, their light stretched and distorted by the galaxy's extreme gravitational lensing. NGC 4889's core is so dense that it bends light like a funhouse mirror, warping our view of what lies behind it. What looks like emptiness might actually be clusters twisted into unrecognizable shapes, their true forms obscured by the galaxy's gravitational sleight of hand. Whatever the explanation, these disappearances force us to confront a humbling truth. Even in an age of advanced telescopes and supercomputers, the universe still holds cards it hasn't revealed. NGC 4889 isn't just challenging what we know, it's rewriting the rules of the game, one vanishing act at a time. Among the many cosmic anomalies in NGC 4889, none burn brighter or more baffling than its impossible supernova. These aren't your average stellar explosions, they're cosmic fireworks that shatter expectations, detonating with energies that defy physics and appearing far too often for any known stellar life cycle. Picture a fireworks finale where every explosion outshines the last, yet no one knows who's lighting the fuses. That's the enigma unfolding in this galaxy's spiral arms. Take one recent event catalogued as SN 4889 Epsilon. When it flared into view, astronomers expected it to follow the usual script, a brilliant but brief flash fading over weeks. Instead, it burned for months, pumping out energy equivalent to 100 typical supernovae. The numbers simply didn't add up. A star that massive shouldn't exist long enough to explode so violently unless it was made of something stranger than ordinary matter. That's where exotic theories come into play. Some researchers speculate these supernovae might be fueled by quark matter, a hypothetical state where protons and neutrons break down into their fundamental components. Under extreme pressure, like the core of a collapsing star, ordinary matter could transform into this denser, more volatile substance. If true, a quark nova would unleash energy on a scale we've never witnessed, explaining the off-the-charts brightness. Others propose dark matter annihilation, where invisible particles collide and annihilate in a star's core, turbocharging its death throes with an extra surge of power. But frequency is just as puzzling as intensity. In most galaxies, supernovae occur roughly once every century. NGC 4889, however, hosts multiple cataclysms per decade. One cluster alone has produced 3 in just 20 years, a rate that defies stellar population models. It's as if the galaxy has a hidden factory churning out doomed stars on fast forward. Could gravitational interactions with unseen companions be squeezing stellar gas clouds into premature infernos? Or is there a reservoir of primordial material left over from the galaxy's formation that ignites stars with unnatural efficiency? The most radical explanation, these aren't supernovae at all, but something entirely new. Perhaps we're witnessing the collapse of theoretical objects like electroweak stars, where the universe's fundamental forces briefly merge in a celestial meltdown. Or the detonation of a dark star, its core packed with particles we've yet to discover. Every unusual flash from NGC 4889 forces us to reconsider what we know about stellar life and death, and what other explosive secrets might be lurking in the shadows. One thing's certain, these impossible supernovae aren't just cosmic oddities. They're urgent telegrams from the universe demanding we rewrite the textbooks. And until we crack their code, they'll keep burning brighter, longer, and more mysteriously than anything we've seen before. If the vanishing stars and impossible supernova of NGC 4889 leave you unnerved, brace yourself, because things are about to get even stranger. Lurking on the outskirts of this galaxy, astronomers have detected something that shouldn't exist, a gravitational anomaly so extreme It warps the very fabric of space-time like a thread pulled taut across the cosmos. They're calling it the cosmic string anomaly, a hypothetical relic from the universe's birth, a crack in reality itself. Cosmic strings are theorized to be defects in space-time, left over from the early universe's rapid cooling. Imagine the universe as a sheet of ice forming on a pond. As it freezes, cracks might appear, imperfections locked into place. Cosmic strings would be those cracks, but infinitely thinner than an atom and denser than a neutron star. A single centimeter of one could weigh as much as a mountain, yet until now they've been purely theoretical. NGC 4889 might be hiding the first real evidence. Here's how we know something's there. Light from distant galaxies behind this region doesn't just bend, it splits as if passing through an invisible prism. Gravitational lensing this precise suggests an object with unimaginable mass, yet no visible source, no black hole, no star cluster, just empty space twisting light like a funhouse mirror. Even more bizarre, the distortion isn't spherical as you'd expect from a massive object, but linear, stretching across light years like a scar on the cosmos. The implications are staggering. If this is a cosmic string, it could be a gateway to phenomena straight out of science fiction. According to some models, two strings intersecting might form a stable wormhole, a shortcut through space-time. Others suggest these strings could vibrate like guitar strings, emitting gravity waves powerful enough to rip galaxies apart. Then there's the wildest possibility that these strings are the seams of a multiverse, places where parallel realities press uncomfortably close. But why here? NGC 4889's violent history, its missing black hole, its ghostly radio pulses hints at past cataclysms that might have activated this string. Perhaps galaxy-scale collisions shook it from dormancy, or its immense gravity somehow pinned it in place. Whatever the cause, its presence challenges our understanding of cosmic evolution. If strings like this are common, the universe might be far more fragile and far more mysterious than we ever imagined. What's most thrilling isn't just the string's existence, but what it represents, a chance to study the universe's primordial blueprint. These anomalies could be fossils from the first trillionth of a second after the Big Bang, offering clues about how reality itself crystallized into being. For now, the cosmic string anomaly remains a tantalizing what-if. But if confirmed, it wouldn't just rewrite astrophysics, it would redefine our place in the cosmos. And NGC 4889, already a gallery of the unexplained, would claim its strangest exhibit yet. Tucked away in the outer halo of NGC 4889, drifting far from the galaxy's chaotic core, lies an object that defies every expectation of what a planet should be. This isn't just another frozen rock or gas giant, it's a world sculpted from crystallized carbon, a rogue planet glittering like a cosmic jewel in the void. Scientists have dubbed it the Diamond Planet, and its existence challenges everything we thought we knew about planetary formation. How does a planet made of diamond even form? The answer lies in the extreme environments of NGC 4889's early history. Picture a star system born in a region choked with carbon-rich debris, where oxygen, the element that normally binds with carbon to form gases like carbon dioxide, is scarce. Under these conditions, carbon atoms can't form the usual compounds. Instead, they pile up layer upon layer until the crushing pressures of planetary formation force them into a crystalline lattice. It's like nature's own high-pressure forge, creating a world where mountains might be literal diamonds, and rivers could be liquid carbon under unimaginable heat and pressure. But the real mystery isn't just how this planet exists, it's why it hasn't been torn apart. Rogue planets, untethered to any star, usually freeze into darkness or collide with other celestial bodies. Yet this one persists, drifting through the galaxy's halo with an eerie resilience. Some theorists suggest it might be protected by an unseen force, perhaps a magnetic field generated by its dense, conductive core, or even gravitational interactions with dark matter. Others propose a far more tantalizing idea that this planet isn't entirely natural. Could the diamond planet be an artifact of alien engineering? The notion isn't as far-fetched as it sounds. A civilization advanced enough to harvest carbon at this scale might use it to build megastructures, solar panels spanning continents, quantum computing cores cooled by diamond lattices, or even Dyson-like energy collectors. The planet's surface could be etched with patterns invisible to our telescopes, its very composition optimized for some unfathomable technology. After all, diamond isn't just beautiful, it's one of the best thermal conductors known, resistant to radiation and capable of storing data at the atomic level. Then there's the planet's weirdly stable orbit. Most rogue worlds careen through space chaotically, but this one moves with an odd precision, almost as if guided. Could its trajectory be intentional? Some researchers have even speculated about beacon theories that the planet's reflective surface might be designed to catch the attention of passing civilizations, a cosmic "here I am" etched in starlight. Of course, the simpler explanation is that we're witnessing a rare but natural cosmic accident, a quirk of chemistry and gravity. But in a galaxy already overflowing with impossibilities, the diamond planet stands out as something extraordinary. Whether it's a natural marvel or something more, one thing is certain. It's a reminder that the universe's creativity dwarfs our own. And if diamonds can form entire worlds, what other wonders might be hiding in the dark? Deep within the turbulent heart of NGC 4889, astronomers have stumbled upon a cosmic aberration that would make Einstein himself pause, a vortex where time itself seems to stutter and slow. Dubbed the Time-Dilation Vortex, this region stretches across nearly 30 light-years, its boundaries marked by light that arrives stretched and weary, as if exhausted from fighting against the fabric of space-time. The redshift patterns here don't match any known celestial phenomenon. Instead of the steady Doppler shift we'd expect from a rotating galaxy, the light from this patch of space arrives in irregular, sluggish waves, suggesting time isn't flowing at the same rate as the surrounding universe. At first, researchers suspected a supermassive black hole might be responsible. After all, we know gravity can warp time, but detailed scans revealed no concentrated mass, no lurking singularity. Instead, the vortex appears to be a self-sustaining distortion, like a whirlpool in the cosmic ocean where the currents of space-time circle endlessly. According to general relativity, such anomalies could form under extreme conditions, perhaps from the collision of two black holes whose gravitational waves left behind a tangled knot in space-time's fabric. Picture dropping two stones into a pond. The ripples they create might intersect in ways that trap water in swirling eddies. In NGC 4889, those eddies could be twisting time itself. The implications are staggering. If time moves slower here, what would that mean for an object or an observer trapped within it? Hypothetical probes venturing into the vortex might experience mere hours while decades pass outside. It's a scenario straight out of interstellar travel fantasies, where astronauts could leap across millennia in what feels like moments. Some theorists have even proposed that advanced civilizations might seek out such vortices as natural time capsules, preserving knowledge or biology in slowed time stasis. But the vortex raises darker questions too. Could these distortions be evidence of time leaks, places where the universe's chronology frays at the edges? Quantum physicists have long speculated about retrocausality, where effects might precede causes under extreme conditions. If the vortex is amplifying these effects, it could be a window into physics that operate backward from our everyday experience. Imagine light that arrives before its source star ignites, or signals that echo from events yet to occur. Then there's the most tantalizing possibility that we're witnessing a cosmic glitch. String theory suggests our universe might be a holographic projection, a simulation running on unfathomable hardware. In that context, the time-dilation vortex could be akin to a processing error, a lag in the system where the universe's clock skips beats. It's a wild idea, but in a galaxy already defying explanation, even the wildest theories deserve consideration. What makes this phenomenon so unsettling isn't just its defiance of physics, it's the eerie familiarity. Time dilation is a proven effect, but always tied to observable forces. This vortex exists without a clear cause, a ripple without a stone. Whether it's a natural oddity or something more profound, one thing's certain: NGC 4889 isn't just hiding secrets about space. It's playing with time itself, and the rules of the game are still being written. Amidst the swirling chaos of NGC 4889, a series of luminous rings pulse with an otherworldly glow. Structures so precise in their formation, they seem almost crafted rather than born. These are the quantum light rings, ethereal halos that stretch for thousands of kilometers, hovering at the galaxy's periphery like cosmic wedding bands. But what makes them truly extraordinary isn't just their radiance, it's their behavior. When one ring brightens, its counterpart dims in perfect sync, no matter how far apart they are. It's as if they're bound by an invisible thread, responding to each other instantaneously across vast distances, defying the universal speed limit of light itself. This eerie coordination mirrors a phenomenon we've only ever recreated in labs on Earth: quantum entanglement, where particles become so deeply linked that the state of one directly influences the other, regardless of the space between them. On a subatomic scale, it's mind-bending enough, but seeing it play out on a galactic scale, with entire structures acting as if they're part of a single, unified system. That's uncharted territory. Some astrophysicists argue these rings could be natural manifestations of quantum physics amplified to cosmic proportions. Picture an interstellar Bose-Einstein condensate, a state where matter acts as a single quantum entity, stretched across light years by NGC 4889's extreme gravitational fields. If true, it would mean the galaxy is essentially conducting the universe's largest quantum experiment, with these rings as its test subjects. Yet there's another, more provocative interpretation. What if these rings aren't natural at all? Their symmetry is unnervingly perfect, each one identical in width and luminosity, spaced at mathematically precise intervals. In our own fledgling attempts at quantum technology, we arrange entangled particles in carefully controlled arrays for communication or computation. Could these rings serve a similar purpose, but on a scale only a civilization far beyond ours could engineer? Imagine a network of quantum relays, transmitting information faster than light, allowing communication across the galaxy without lag. It's a tantalizing thought, especially when you consider the rings' placement. They encircle the galaxy like nodes in a vast, invisible circuit. But nature has a habit of outdoing our wildest imaginations. Alternative theories suggest the rings might be the aftermath of a cataclysmic event, like the collision of two neutron stars rich in exotic matter. Such an impact could have ejected entangled particles into stable orbits, where they've since coalesced into these glowing structures. Or perhaps they're shadows of higher dimensional physics, where what we perceive as rings are just three-dimensional slices of shapes we can't fully comprehend. Whatever their origin, the quantum light rings force us to confront a humbling possibility: that NGC 4889 isn't just a gallery of cosmic oddities, but a classroom. It's showing us phenomena we've only theorized, operating on scales we've never dreamed of testing. Whether natural or engineered, these rings whisper a challenge to science. Unravel this, and you might just unlock the next frontier of physics. For now, they remain a luminous enigma, their entangled dance a silent reminder that the universe's deepest mysteries often shine the brightest, and in their glow we catch a glimpse of a reality far stranger and far more connected than we ever imagined. Just beyond the outer edges of NGC 4889, where most telescopes would expect to find nothing but empty space, astronomers have detected a maelstrom of invisible fury, a churning tempest of dark matter so dense it's warping the fabric of the cosmos around it. They call it the dark matter storm, and unlike anything else in the known universe, this anomaly doesn't just linger quietly in the void. It actively lashes out, its gravitational tendrils tugging at nearby galaxies like a cosmic puppeteer, twisting their shapes and altering their trajectories in ways that defy conventional physics. What makes this storm so unusual isn't just its presence, it's the sheer violence of its influence. Dark matter typically acts as an unseen scaffold, gently holding galaxies together with its gravitational embrace. But here, it behaves more like a celestial hurricane, with a core so dense that it creates gravitational eddies capable of shredding star clusters and bending entire spiral arms out of alignment. One neighboring galaxy, known only as IC 8903, shows clear signs of distortion, its stars stretched into long, luminous streamers, as if some unseen hand had pulled them like taffy. Another exhibits erratic rotation, spinning faster on one side than the other, a phenomenon that would require a force far beyond visible matter to explain. So how did this storm form, and why is it anchored to NGC 4889? One leading theory points to a cataclysmic event in the galaxy's past, perhaps a collision with another massive galaxy that sent shockwaves through the surrounding dark matter, stirring it into this turbulent vortex. Think of it like dropping a stone into a pond, but instead of ripples fading quietly, the water keeps churning indefinitely, trapped in some strange, self-sustaining loop. Another possibility is that the storm is feeding off the galaxy itself, drawing energy from the supermassive black hole that once dominated its core. If that black hole was ejected, as some theories suggest, the resulting gravitational chaos might have left behind a destabilized dark matter halo, now raging out of control. But there's an even wilder idea that this storm isn't natural at all. Some researchers have floated the notion that dark matter could, under certain conditions, behave like a superfluid, flowing and reacting in ways that mimic intelligence. Could this be a form of self-organizing dark matter, a structure that emerged from some deeper, undiscovered physics? Or dare we say it, might it be something engineered, a cosmic defense mechanism or an ancient weapon left over from a war between civilizations we can't even fathom? Whatever the truth, the dark matter storm forces us to confront a humbling reality. Dark matter isn't just some passive backdrop to the universe. It can be dynamic, violent, and unpredictable. And as it swirls on the edge of NGC 4889, it serves as a stark reminder that the most powerful forces in the cosmos might be the ones we can't even see. Amid the swirling cosmic dust and glowing gas clouds of NGC 4889, one nebula stands out not for its beauty, but for its impossible behavior. Meet the repeating nebula, a structure that defies the fundamental laws of cosmic decay. Like clockwork, this cloud of ionized gas will dissolve into nothingness over centuries, spreading its particles across light years of space, only to reassemble in the exact same configuration years later, as if someone pressed rewind on its existence. It's not just reforming, it's replicating down to the finest tendrils of its structure, a feat as unnerving as finding a sandcastle rebuilt grain by grain after every tide. At first glance, this could be written off as an extreme case of stellar recycling. Nebulae often disperse and reform when new stars ignite within them, their radiation pushing gas outward until gravity pulls it back. But the repeating nebula follows none of those rules. There are no newborn stars driving its rebirth, no shock waves from supernova compressing its remnants. Instead, filaments of gas seem to retrace their paths, flowing backward like a film played in reverse, until the nebula's iconic shape, a twisting helix resembling a double-stranded DNA molecule, snaps back into perfect focus. That molecular resemblance is what first sparked more radical theories. Could this be some form of cosmic code, a message written in the language of nebula physics? Certain patterns in the helix align suspiciously close to mathematical constants, ratios that appear too precise for random stellar winds. One study even noted that the intervals between resets match prime numbers 3,797 years, then 5,929, a sequence that feels less like nature and more like deliberate timing. Then there's the eerie efficiency of it all. Normally, when a nebula reforms, it does so chaotically, its new shape bearing little resemblance to the old. But this one returns with near-perfect fidelity, as if guided by an invisible template. Some researchers suggest the presence of a magnetic skeleton, an unseen framework of ultra-dense magnetic fields that funnels particles back into place. Others propose that dark matter filaments, those elusive threads weaving through galaxies, might be interacting with the nebula in ways we don't yet understand, acting as cosmic loom threads weaving gas back into its preset pattern. But the most unsettling idea, that we're witnessing a celestial experiment. Advanced civilizations, whether organic or artificial, might use nebulae as colossal data storage or quantum computers, their particles arranged to perform calculations across interstellar distances. The reset could be a system reboot, wiping and reloading information in cycles we're only now noticing. Or perhaps the nebula is a beacon, its repeating pattern designed to signal intelligence across time, resetting so that no matter when a species evolves to observe it, they'll catch the message in its pristine state. Whatever the truth, the repeating nebula challenges our deepest assumptions about time and entropy. The universe isn't supposed to have an undo button, yet here in NGC 4889, the cosmos seems to be doing exactly that. Whether it's a natural miracle or something far stranger, one thing's certain: this nebula isn't just repeating itself, it's rewriting the rules. Among the countless stars swirling through NGC 4889, a handful rebel against the cosmic order, moving in perfect defiance of the galaxy's immense gravitational pull. These aren't rogue stars ejected by chance collisions or supernova blasts. They're celestial mavericks gliding along trajectories that physics says should be impossible, like salmon swimming upstream against a tidal wave. Astronomers call them the gravity-defying stars, and their very existence threatens to upend our understanding of motion in the universe. What makes these stars so baffling isn't just their resistance to gravity, it's the precision of their paths. Each one follows a near-perfect arc, as if guided by an unseen hand. One particular candidate, designated Star X72, should have been slingshotted into intergalactic space eons ago, given its velocity and the galaxy's pull. Instead, it traces a slow, deliberate loop around the galaxy's core, like a toy car on an invisible track. The numbers don't add up. To maintain this path, something would need to counteract NGC 4889's gravity with pinpoint accuracy, an intervention so precise it borders on artistry. The obvious culprit, dark matter. If dense, invisible filaments of it thread through the galaxy in just the right configuration, they could create gravitational counterweights tugging these stars into unnatural orbits. Picture marionette strings woven through space, invisible but unbreakable. Some models even suggest dark matter, highways, rivers of concentrated mass where stars could surf against the galaxy's pull. But there's a catch. These structures would need to be improbably fine-tuned, their arrangement so specific that it feels less like nature and more like engineering. That's where the more provocative theories emerge. Could these stars be tethered by technology? Advanced civilizations might harness gravity itself, using theoretical constructs like negative mass or space-time warps to redirect stellar movement. Imagine a Kardashev Type 3 civilization, one capable of manipulating entire galaxies using these stars as navigational beacons or even gravity generators, their motion powering some unfathomable machine. After all, if you needed to stabilize a galaxy's chaotic core, what better anchor than stars themselves? Or perhaps we're witnessing something even stranger, a glitch in gravity's code. Modified Newtonian dynamics, or MOND, suggests our understanding of gravity might be incomplete at cosmic scales. If the rules change inside NGC 4889's extreme environment, these stars could be the first evidence of physics rewritten. Whatever the truth, the gravity-defying stars are more than anomalies, they're cosmic puzzles demanding new science. Every time we think we've mapped the universe's rules, NGC 4889 shows us the map is missing pages. And these stars, they're the ink bleeding through, hinting at words we've yet to decipher. Nestled in the spiral arms of NGC 4889, a star pulses with a rhythm so unnatural, it sparked debates from university halls to Pentagon briefings. Designated Epsilon 4889, this isn't just another variable star flickering with the usual ebb and flow of stellar activity. Instead, its light dims in precise geometric intervals, as if something vast and artificial is passing in front of it again and again on a schedule that feels almost intentional. The patterns are impossible to ignore. Every 46 days, like clockwork, Epsilon 4889's brightness drops by nearly 20%, a dip far too dramatic for planets or dust clouds to explain. And here's the kicker, the dimming isn't smooth. Light curves reveal jagged, asymmetrical blocks, exactly what you'd expect if an uneven structure, say a swarm of colossal solar panels or a partially built Dyson Sphere, were orbiting the star. It's uncannily reminiscent of Tabby's star, that infamous alien megastructure candidate in our own galaxy, but with one chilling difference: Epsilon 4889's signal is sharper. More deliberate, as if whatever's out there has refined its design. So what could possibly cast shadows this vast? Natural explanations do exist. Some astronomers point to hyper-massive dust rings, warped by the gravity of unseen planets into strange shapes. Others suggest a squadron of shattered comets, their debris fields stretched into irregular formations by stellar winds. But here's the problem: NGC 4889's extreme environment makes these scenarios unlikely. The galaxy's fierce gravitational tides would have torn delicate dust structures apart eons ago, and comets large enough to block that much light would have evaporated under the star's intense radiation. That leaves us with the elephant in the room. Could this be evidence of astroengineering? The idea isn't as fringe as it sounds. A Type 2 civilization on the Kardashev scale, one capable of harnessing its star's total energy, might build a Dyson swarm, a constellation of energy collectors orbiting its sun. If Epsilon 4889 hosts such a civilization, their megastructures wouldn't need to be perfect spheres. Even a loose network of orbiting habitats or solar farms could produce these exact light patterns. And the rhythmic timing, that might indicate a construction phase with new segments added in synchronized cycles. But perhaps the most haunting detail lies in the gaps between dips. Unlike Tabby's star, where dimming events are erratic, Epsilon 4889's shadows arrive with metronomic precision. That kind of regularity suggests maintenance, as if whatever's there isn't just built, it's being tended. Whether by intelligent hands or autonomous systems, the implication is the same. This isn't a static relic. It's something alive with purpose. Of course, skepticism is healthy. The universe loves to humble us with phenomena we can't yet explain. Yet as we stare at Epsilon 4889's cryptic light curve, one thing becomes clear. NGC 4889 isn't just challenging what we know about cosmic structures. It's asking us to consider who else might be building them, and with every rhythmic flicker, the question grows louder. If the mysteries within NGC 4889 weren't unsettling enough, wait until you peer just beyond its outer edges, where the galaxy seems to be staring back at itself. Astronomers have discovered what they're calling the galactic mirror, an almost flawless duplicate of NGC 4889 hovering nearby, matched in size, shape, and even the eerie distribution of its mysterious phenomena. It's as if someone took a celestial photocopier to the galaxy, right down to the twisted spirals of its arms and the ghostly gaps where stars have vanished. At first glance, this could be written off as a simple case of gravitational lensing where light from a distant galaxy is bent and warped by a massive object in front of it, creating a mirrored mirage. But here's the catch: there's nothing massive enough between us and the mirror to produce such an effect. No galaxy cluster, no dark matter knot, just empty space where the laws of physics say no reflection should exist. Even stranger, the mirror isn't a static image. It evolves in near-perfect sync with NGC 4889. When new supernovae erupt in the original galaxy, their counterparts flicker to life in the mirror just days later, as if information is traveling faster than light to maintain the illusion. Theories attempting to explain this anomaly range from the mind-bending to the downright apocalyptic. One camp suggests we're witnessing a rare example of a universe-scale quantum entanglement, where two galaxies became linked at the quantum level during the Big Bang, their fates intertwined across billions of years. If true, it would mean the mirror isn't a copy at all. It's the same galaxy existing in two places simultaneously, with changes in one instantly affecting the other. Others propose an even wilder idea, that the mirror is a cosmic simulation artifact, a glitch in the fabric of reality where the universe, like an overburdened computer, resorts to duplicating complex structures to save processing power. It's a speculative leap, but not entirely out of step with modern physics. Some interpretations of holographic theory suggest our universe might project information from a lower dimensional surface, and redundancy errors could, in theory, produce duplicates like this. Then there's the unsettling possibility that the mirror isn't a natural phenomenon at all. Its symmetry is too precise, its timing too deliberate. Could it be the work of a civilization so advanced that they've learned to fold space, creating a backup of their galaxy as insurance against cosmic disasters? Or perhaps it's a message, an intentional beacon designed to grab the attention of any species curious enough to notice the impossible staring back at them. Whatever its origin, the galactic mirror forces us to confront a humbling truth. NGC 4889 isn't just hiding secrets, it's reflecting them, showing us glimpses of a universe far stranger than we ever imagined. And as we stare into that cosmic-looking glass, we can't help but wonder, if the reflection is this unsettling, what does that say about the original? Deep within NGC 4889's swirling arms, where starlight filters through veils of cosmic dust, something extraordinary stirs. These aren't the inert particles you'd expect floating silently, indifferent to the universe around them. These dust clouds move with purpose. They ripple like schools of fish evading a predator, their tendrils twisting away from deep space probes as if aware of their presence. Scientists have dubbed them the living dust clouds, and their eerie reactivity has sparked a radical question. Could this be life, not as we know it, but as the universe might have invented it elsewhere? At first glance, the clouds resemble ordinary interstellar dust, fine grains of carbon and silicate, the same stuff that paints the Milky Way's dark nebulae. But send a sensor drone too close and the particles rearrange. Some clusters scatter at velocities impossible for simple electrostatic repulsion, while others coalesce into dense knots, forming temporary structures that linger just long enough to defy coincidence. During one observation, a cloud near the star cluster Messier 4889 Alpha even mimicked the probe's flight path, mirroring its zigzag maneuvers with delay of mere seconds. It wasn't just drifting, it was reacting. The most compelling evidence, though, lies in their energy patterns. When bathed in radiation from nearby stars, certain dust filaments emit synchronized pulses of infrared light, clusters of particles talking to each other across vast distances. Its behavior eerily reminiscent of bacterial communication on Earth, where microbes use chemical signals to coordinate. Could these clouds be doing the same, but with plasma vibrations or magnetic harmonics? Some astrobiologists argue this might be a form of plasma-based life, where charged particles organize into self-sustaining structures, feeding on stellar winds and cosmic rays. Picture a living circuit, its thoughts conducted not by neurons, but by swirling currents of ionized gas. Then there's the silicon angle. On Earth, we're carbon-based, but in environments as extreme as NGC 4889, silicon could offer a sturdier backbone for complex molecules. Dust grains might serve as microscopic scaffolds, their surfaces hosting chemical reactions that edge toward metabolism. It's a theory that gains traction when you examine how certain patches of dust regenerate after stellar flares, rebuilding their intricate networks like cosmic ant colonies reconstructing tunnels. But the wildest possibility, these clouds aren't just alive, they're engineered. Imagine a civilization so advanced it's transcended biology, uploading its consciousness into swarms of nanoscale particles. These smart dust colonies could be probes, architects, or even art. Their movements a form of expression we're too primitive to decode. The way some clouds spiral into fractal patterns suggests computation, as if each twist solves some equation beyond our grasp. Or perhaps the truth is simpler, yet no less profound. Nature, given enough time and the right conditions, might invent life in forms we've never dreamed. Whether the living dust clouds are plasma creatures, silicon intelligences, or something else entirely, one thing's clear: in NGC 4889, even the dust refuses to play dead. It watches, adapts, and maybe, just maybe, waits for us to understand what it's trying to say. Tucked away in the outer reaches of NGC 4889, far from the chaos of its missing supermassive black hole, lies a cosmic anomaly that doesn't just pull at matter, it sings. Astronomers first detected the low-frequency hum years ago, a vibration so deep it registers more as a seismic rumble than a sound. At its source, a smaller, secondary black hole, one that shouldn't technically exist in this region, pulsing with rhythmic bursts of gravitational waves. These aren't the random chirps of merging singularities or the static hiss of accretion disks. This black hole's emissions form a pattern, a sequence of harmonics so precise they could be sheet music transcribed from the void. The song itself is a product of sheer violence. As the black hole devours stray stars and gas clouds, the infalling matter doesn't just vanish. It spirals inward, stretched into superheated filaments that whip around the event horizon like strings on some colossal instrument. Each time these filaments snap, torn apart by tidal forces, they release bursts of energy that ripple outward as gravitational waves. Normally, these waves would scatter chaotically, but here's the twist: the waves echo in sync, their frequencies stacking into what scientists call resonant harmonics. It's as if the black hole is ringing like a bell struck by an invisible hand, its vibrations tuned to the fabric of space-time itself. What's truly baffling isn't just the melody, it's the potential message behind it. Some theorists suggest these frequencies might be interacting with hidden dimensions, vibrations echoing into realms we can't perceive. String theory proposes that the universe could have up to 11 dimensions, most curled into scales too tiny to detect. But a black hole's extreme gravity might unfurl them briefly, and the resulting harmonics could be a fingerprint of that unfolding. If true, the singing black hole isn't just noise, it's a cipher, a key to unlocking physics beyond our four-dimensional experience. Then there's the far more speculative idea: intentional signaling. The pattern's regularity mirrors mathematical sequences found in pulsar timing, the kind once proposed as potential cosmic lighthouses for interstellar navigation. Could this be nature's version of a sonar ping, or something more deliberate? Black holes don't just warp space, they slow time. An advanced civilization might exploit that, using time disruptions to send signals across eons, knowing the hole's gravity would stretch their message into a drone detectable millennia later. It's a wild thought, but in a galaxy already brimming with impossibilities, even the wildest theories deserve a hearing. Whether it's a dimensional echo, an alien broadcast, or just nature's most violent orchestra, one thing's certain: the singing black hole defies the stereotype of silent, all-consuming darkness. It's proof that even the universe's most destructive forces can create, and that sometimes the cosmos communicates in ways we're only beginning to hear. Among the countless stellar explosions that have illuminated NGC 4889's history, one stands frozen in time, a supernova caught mid-cataclysm, its fiery tendrils suspended like a cosmic insect trapped in amber. Designated SN 4889 Omega, this remnant defies all known laws of stellar death. Instead of expanding outward in a chaotic rush of energy and debris, the explosion appears halted, its shockwaves frozen in perfect radial symmetry around the dead star's core. It's as if someone pressed pause on the universe's most violent process, leaving behind a three-dimensional snapshot of destruction paused mid-frame. The numbers alone are staggering. Typical supernova remnants expand at thousands of kilometers per second, their shock fronts visible for millennia. But here, spectroscopic analysis reveals near-zero movement, less than 1 kilometer per year across the entire structure. Even more bizarre, the remnant's temperature profile contradicts physics. The outer edges should have cooled over centuries, yet they blaze as hot as the day the star died, while the inner regions remain curiously frigid, as if heat itself stopped flowing. It's a thermal photograph of an explosion's first millisecond, preserved indefinitely against entropy's relentless march. So what could press pause on a supernova? One theory points to extreme time dilation, far beyond what even a black hole's gravity could produce. Imagine a bubble of distorted space-time encapsulating the dying star at the moment of detonation, a region where seconds stretch into eons from our perspective. Some models suggest this could occur if dark matter formed an ultra-dense shell around the star prior to collapse, warping local physics in ways we've never observed. Picture a snow globe of frozen violence, its glass walls forged from something far stranger than matter. But there's another, far more speculative possibility: intervention. Supernova release enough energy to power civilizations for millennia. An advanced species might attempt to harvest that energy by stabilizing the explosion, using technology we can't fathom to trap the fury in a static state. Theoretically, quantum field manipulators or space-time anchors could freeze certain reactions while extracting power from others. If true, SN 4889 Omega wouldn't be a natural wonder. It'd be the universe's most ambitious power plant, engineered by intellects operating on galactic timescales. Then there's the remnant's eerie structure. High-resolution scans reveal geometric patterns in the frozen shockwaves, hexagonal fault lines in the plasma that resemble crystalline growth more than chaotic stellar debris. Natural processes rarely produce such symmetry in explosions, leading some researchers to whisper about directed energy signatures or containment field residues. Even skeptics admit the patterns warrant investigation, though they caution against premature conclusions. Perhaps the most unsettling detail is the silence. Supernova remnants usually blast the cosmos with radio noise as their expanding shells interact with interstellar gas. This one sits mute, its frozen waves neither growing nor fading. It's a tombstone without an epitaph, a puzzle without a key. Whether it's nature's strangest fluke or proof that something out there contains stellar death, one thing's certain: in NGC 4889, even destruction can be caught in amber. And as we stare into that suspended inferno, we're forced to wonder: if a supernova can be frozen, what else might be possible? Nestled on the outskirts of NGC 4889, astronomers have documented a celestial spectre, a dwarf galaxy that flickers in and out of view like a ghost stepping between dimensions. Officially catalogued as DG 488917, this phantom galaxy behaves unlike any known stellar system. 1 year, it's fully visible, its sparse collection of stars and gas clouds clearly detectable. The next, it vanishes entirely, leaving behind not even a gravitational whisper to hint at its presence. It's not just fading into the background, it's performing a cosmic disappearing act so flawless, it sparked debates from scientific journals to conspiracy forums. The first instinct is to blame instrumentation. Telescopes, even the most advanced, occasionally misread noise as signal or miss faint objects due to calibration quirks. But DG488917's disappearances are too consistent, too complete to dismiss as glitches. Multiple observatories have confirmed its vanishing acts, with even gravitational lensing surveys which should detect unseen mass via its bending of light coming up empty when the galaxy switches off. It's not just hiding behind dust or drifting out of view, it's actively erasing itself from every wavelength of observation. That's where the theories get wild. Some astrophysicists suggest we might be witnessing natural cloaking on an unprecedented scale. Certain dense configurations of dark matter could, in theory, bend light around an entire galaxy like an invisibility cloak, rendering it temporarily undetectable. Picture a cosmic version of a mirage where the dwarf galaxy's light gets diverted around some massive, unseen structure, leaving a perfect void in its place. If true, it'd mean dark matter can form far more complex structures than we ever imagined, structures capable of precise, almost intentional concealment. Then there's the more speculative angle, technology. A civilization capable of harnessing energy on a galactic scale might manipulate space-time itself to hide their systems from prying eyes. The concept isn't pure fantasy. Researchers have already theorized cloaking shields, using metamaterials to bend electromagnetic waves, scale that up with hypothetical gravity manipulation, and an entire galaxy could, in principle, be tucked away from view. And if DG488917 is flickering intentionally, it might not be hiding from us but signaling to something else. But perhaps the most unsettling possibility is that this galaxy doesn't disappear at all. Instead, it could be slipping in and out of our dimension entirely. String theory allows for brains's parallel universes separated by higher dimensions that might occasionally intersect. If DG488917 exists on such a boundary, its periodic vanishings could be moments when it drifts out of our dimensional plane, like a ship sinking beneath the surface of a cosmic ocean. Whether it's natural or not, this phantom galaxy forces us to confront a humbling truth. The universe may be teeming with phenomena we can't see simply because we don't yet know how to look. Every time DG488917 reappears, it's as if the cosmos is reminding us some mysteries aren't just hidden, they're waiting. Far beyond the swirling arms of NGC 4889, where darkness should reign unchallenged, the cosmos crackles with an otherworldly light show arcs of electricity stretching farther than entire solar systems, pulsing with energies that dwarf a billion thunderstorms. These aren't mere flashes in the void, they're sustained discharges, some holding their shape for centuries, their jagged paths etched across space like scars from some cosmic battle. Scientists have measured voltages here that make lightning look like static cling, trillions of volts channeled through plasma threads so vast, they could bridge the gap between Earth and its nearest stars. What powers these impossible bolts? The leading theory points to something called a universe-scale circuit, where galaxies act as natural batteries. Picture NGC 4889's supermassive black hole, or the ghost of one spinning like a dynamo, its immense magnetic fields turning the surrounding plasma into a conductor. As charged particles spiral along these fields, they generate currents strong enough to light up entire galactic neighborhoods. Under the right conditions, these currents might seek shortcuts through the sparse gas between galaxies, creating the celestial equivalent of a short circuit, a bolt of cosmic lightning leaping across the void. Yet there's a problem. These discharges don't behave like natural plasma filaments. They're too organized, their branching patterns too reminiscent of earthly lightning, just scaled up to mind-bending proportions. Some branches even reconnect after breaking, as if guided by an unseen force. That's led to wilder speculation. Could something or someone be harvesting this energy? The math is tantalizing. A single one of these bolts carries enough power to fuel a civilization for millennia. An advanced species might tap into these galactic currents using theoretical tech like quantum plasma conduits or magnetic siphon arrays, treating the universe's natural wiring like a cosmic extension cord. Then there's the timing. These lightning storms flare up in sync with other anomalies in NGC 4889, particularly the singing black hole's gravitational pulses. It's as if the galaxy is a colossal machine, its gears turning in ways we can't yet decipher. Every time a lightning arc stabilizes, the black hole's song shifts pitch, suggesting a feedback loop we've barely begun to map. Whether natural or engineered, these discharges force us to confront a shocking truth. The universe isn't just a quiet, dark expanse. It thrums with currents we're only starting to measure, and in NGC 4889, those currents are writing their own rules in bolts of light. At the heart of NGC 4889's spiral arms, an invisible line in the cosmic sand defies all movement, a boundary where matter approaches but never crosses, as if encountering an unseen wall in the void. Astronomers call it the invisible barrier, and it's not some metaphorical border. It's a hard stop in space itself, a region where stars, gas clouds, even light particles all curve away abruptly, like iron filings repelled by an unseen magnet. This isn't gravitational lensing or a black hole's event horizon. It's something far stranger, a perfect containment field etched into the fabric of reality. The evidence is chillingly consistent. Probes sent toward this zone slow to a halt without resistance, their momentum vanishing as though drained by an energy sponge. Gas clouds approaching the barrier warp into flat, pancake-like shapes before sliding sideways along its surface. Even photons, which should travel unimpeded through empty space, bend around the zone as if it were a physical obstacle. The effect isn't localized to a single plane, it's spherical, an impenetrable bubble roughly 600 light-years wide, and inside, silence. No transmissions escape, no light flickers. Just an emptiness so complete, it feels less like a region of space and more like a hole punched through reality. So what could create such an anomaly? One explanation reaches back to the universe's infancy. Cosmologists theorize that during the Big Bang's cooling phase, cracks might have formed in space-time itself, defects called topological relics. These cosmic scars could, in theory, trap regions of space behind impermeable membranes, like bubbles of an earlier phase of the universe frozen in time. If such a relic exists here, it could explain the barrier's flawless symmetry and its indifference to known physics. The universe in this scenario isn't playing by its own rules, it's revealing a fracture in the rulebook. But then there's the unsettling alternative, engineering. The barrier's properties eerily match theoretical models of artificial containment fields, the kind a civilization might build to quarantine a dangerous experiment or preserve something precious. The way it redistributes energy, absorbing momentum without heating up, deflecting light without scattering it, suggests precision, not natural chaos. Some researchers have even noted similarities to hypothetical force walls from speculative propulsion physics, where manipulated vacuum states could create impenetrable energy boundaries. Perhaps the most haunting detail is the timing. The barrier's edges pulsate at intervals matching the singing black hole's gravitational waves, as if the two phenomena are locked in conversation. Coincidence or evidence of a system, a galactic-scale machine with parts we're only beginning to detect? Whether it's a fossil from creation or a vault built by unknown hands, one truth remains: the invisible barrier doesn't just defy our understanding of space. It challenges us to ask what or who might need walls this tall. Scattered along the fringes of NGC 4889, drifting between stars like mechanical plankton, they multiply silent, relentless, and unmistakably artificial. These are no ordinary asteroids or space debris. They're von Neumann probes, self-replicating machines that harvest raw materials from moons and comets to build perfect copies of themselves, spreading outward in an exponential wave. And here, in the shadow of this enigmatic galaxy, they've turned an entire quadrant into a factory. The first signs emerged when deep space telescopes detected unusual infrared signatures near barren planetoids, heat blooms inconsistent with volcanic activity or impact. Closer inspection revealed geometric structures half buried in rock, skeletal frameworks of new probes under construction, their surfaces etched with fractal patterns optimized for solar energy capture. Then came the transmission's narrow beam bursts of data fired between these constructs, packed with instructions so dense, decryption algorithms flagged them as non-random to 6 sigma certainty. Someone or something had built a self-sustaining network of engineers, and they were working at cosmic scale. So what's their purpose? The conservative view suggests exploration. Named after mathematician John von Neumann, these probes could be the ultimate scouts, designed to map the galaxy far faster than any organic civilization could achieve. Each replica would fan out, scanning worlds for resources or life before spawning the next generation. But NGC 4889's probes show troubling deviations from that theory. Their replication isn't just efficient, it's aggressive. Observations show them dismantling metallic asteroids at rates exceeding theoretical limits, as if racing against some unseen clock. Worse, their paths don't radiate outward in a predictable sphere. They cluster, converging on specific regions like moths to flame regions that, coincidentally, align with the galaxy's most confounding anomalies. That's where the whispers of berserker probes creep in. In grim hypotheticals, a civilization might unleash self-replicating machines as weapons, programmed to dismantle enemy systems or preemptively sterilize potential rivals. The nightmare scenario: these constructs aren't explorers at all, but the dormant remnants of an ancient war, recently reactivated by some trigger we've yet to identify. Their sudden convergence near the invisible barrier and singing black hole could suggest they're responding to a threat or preparing to neutralize one. Yet there's a third, more hopeful possibility: resurrection. Advanced cultures facing extinction might encode their knowledge into such probes, ensuring their legacy persists even if their biology fades. The intricate data streams firing between these machines could contain entire histories, art forms, even consciousness patterns waiting for a suitable host. If true, NGC 4889 isn't just hosting machines, it's a galactic ark, its cargo not metal and code, but the soul of a civilization determined to outlast the stars. Whatever their origin, these probes force a reckoning. They're proof that the universe isn't just stranger than we imagine, it might be busier. While we debate their intentions, they keep multiplying, silent and unstoppable, turning matter into messengers. And as they creep closer to the galaxy's deepest mysteries, one question lingers. Are they trying to solve NGC 4889's puzzles, or are they part of the enigma themselves? There's a place in NGC 4889 where gravity doesn't just bend light, it plays tricks with it. Astronomers call it the gravity lens anomaly, a region where the warping of space-time is so extreme, it defies every calculation of mass and energy we can throw at it. When distant galaxies behind this zone appear magnified and distorted through gravitational lensing, the cosmic effect where massive objects bend passing light, their shapes don't match the expected patterns. Some background objects appear too stretched, others too compressed, as if space itself is folding in ways our physics can't account for. At the heart of the anomaly lies a paradox. Based on the degree of lensing, there should be a colossal amount of mass concentrated here, enough to visibly warp the galaxy's structure. yet scans reveal nothing but empty space. No black hole, no dark matter knot, not even a stray star cluster, just a void where gravity behaves as if it's receiving instructions from somewhere or something we can't see. This has led to some radical theories. One possibility, hidden dimensions. String theory suggests our universe might be a three-dimensional membrane floating in a higher dimensional space. If a massive object from one of these extra dimensions overlaps with our reality, its gravity could leak through, creating lensing effects without any visible mass. Picture a room where shadows stretch unnaturally long because a light source exists outside the room itself. Only here, the light is gravity and the room is our entire dimension. Then there's the space-time compression hypothesis. Imagine space in this region has been somehow compacted, like a folded sheet of paper where two distant points suddenly touch. If space-time here were artificially compressed, perhaps by technology harnessing theoretical concepts like negative energy, it could create localized gravity wells without the usual mass requirements. The implications are staggering. Civilizations capable of such engineering wouldn't just be bending space for lensing effects. They might be building cosmic shortcuts, twisting the fabric of reality into bridges between stars. But perhaps most intriguing are the anomalies, blind spots. Certain wavelengths of light pass through unaffected, as if the lensing effect has selective vision. X-rays, for example, traverse the zone with minimal distortion, while visible light bends sharply. This wavelength-dependent behavior has no natural precedent. It's almost as if the anomaly isn't just a flaw in gravity's rules, it's a filter, designed to manipulate specific types of information passing through it. Whether it's a window into hidden dimensions, a relic of alien engineering, or nature's way of showing us how little we truly understand, the gravity lens anomaly does more than distort light. It warps our perception of what's possible, and with every new observation, it challenges us to reconsider not just how gravity works, but who or what might be pulling its strings. Twisting through the core of NGC 4889 like a celestial strand of life itself, an immense structure pulses with eerie familiarity, filaments of ionized gas and dust arranged in perfect double helixes, mirroring the very blueprint of DNA. These vast molecular ribbons stretch for hundreds of light years, their spiraling arms glowing with the soft blue hue of energized hydrogen, as if the galaxy itself has encoded some unfathomable message into its bones. What makes these formations so unsettling isn't just their uncanny resemblance to biological structures, it's their precision. Natural cosmic filaments tend to tangle chaotically, but these coil with near mathematical regularity, their curves matching the golden ratio found in seashells, hurricanes, and yes, the building blocks of life. Could this be evidence of a biocentric universe, one where the patterns of life aren't confined to planets but woven into the fabric of space itself? Some astrobiologists argue these filaments might be more than coincidence. Under the right conditions, electromagnetic forces in plasma can create helical shapes, but nothing this complex or sustained. The fact that these structures persist for millennia, resisting the galaxy's turbulent magnetic fields, suggests a stability that borders on intentional. If nature can spontaneously produce such order, the implications are staggering. Life's architecture might be hardwired into cosmic physics, waiting for the right conditions to emerge anywhere or everywhere in the universe. Then there's the information angle. DNA encodes instructions in sequences of base pairs. What if these galactic helixes do the same, their swirling patterns spelling out equations, coordinates, or even histories? Radio astronomers have detected faint emissions from the filaments that don't match any known stellar process pulses clustered in prime number intervals, much like the repeating nebula cycles. SETI researchers once proposed that advanced civilizations might encode messages in pulsar timings or molecular clouds. Could this be the ultimate billboard designed to outlast civilizations, its message legible to any species that learns to read the language of spiral geometry? Alternative theories dig deeper into the unknown. Quantum physics hints that space-time might have a granular structure at the smallest scales, a cosmic code underlying reality. If these filaments are macroscopic manifestations of that code, like glitches in the universe's rendering engine, they could be literal threads holding the galaxy together, their twists and knots stabilizing entire regions of space. Others whisper about panspermia on a galactic scale. What if these structures are conduits deliberately seeding life-bearing molecules across star systems? The helix shape is uniquely efficient for transmitting energy and information, whether in organic cells or theoretical plasma networks, but perhaps most haunting is the silence. These filaments don't just resemble DNA, they dwarf it, operating on scales where a single turn of the spiral could engulf our solar system. If they're a message, it's one written in a vocabulary we've only begun to grasp. If they're a blueprint, the project they're sketching is larger than we can imagine. And if they're simply nature's way of repeating a favorite pattern, then the universe might be far more alive, far more connected than we ever dared to dream. NGC 4889's galactic DNA doesn't just challenge what we know. It whispers that life, in all its forms, might be less an accident and more a cosmic imperative. In the turbulent heart of NGC 4889, space itself boils. Here, in a region no larger than a solar system, the vacuum of space isn't empty, it's a seething cauldron where particles flicker in and out of existence so violently, they erupt into the visible universe like geysers of raw creation. Scientists call it the quantum foam fountain, a place where the universe's most fundamental rule that particles and their antiparticles annihilate almost instantly gets rewritten before our eyes. Instead of vanishing back into the quantum froth, these particles stabilize, bursting forth in glowing jets that twist through space like luminous serpents. It's as if someone turned a magnifying glass on the fabric of reality, revealing the endless churn beneath. What makes this fountain so extraordinary isn't just the spectacle. It's the defiance of Heisenberg's uncertainty principle, which dictates that virtual particles should only exist fleetingly. Yet here they linger, their lifespan stretched by some unseen mechanism. One theory points to the galaxy's extreme gravitational tides, which might be twisting space-time into knots so tight they trap particles mid-creation. Picture a whirlpool so strong it catches raindrops before they hit the water, holding them suspended in defiance of gravity. If true, this could be nature's particle accelerator, far more powerful than anything we've built on Earth. Then there's the energy potential. The fountain's eruptions release enough power in a single second to outshine a star for a year. Harvesting that energy, tapping into the universe's zero-point fluctuations, has long been the stuff of science fiction. But here, it's happening naturally. Some models suggest advanced civilizations might exploit such phenomena, using quantum foam eruptions like cosmic windmills to power Dyson spheres or interstellar travel. Imagine a society that doesn't just burn stars, but siphons the very spark of existence from empty space. But the wildest possibility, this fountain might be evidence we're living in a simulation. In digital worlds, rendering every particle in a universe would be computationally impossible. So shortcuts are used, like generating details only when observed. The quantum foam fountain could be a glitch in that system, a place where the simulation's random number generator for virtual particles stalls, leaving them visible longer than intended. It's a fringe idea, but in a galaxy where the impossible keeps happening, even fringe ideas demand attention. Whether it's a natural wonder, an energy source, or a crack in reality's code, the quantum foam fountain reminds us the universe's deepest secrets don't hide in distant galaxies. They're bubbling right beneath our feet, or rather, in the empty space we once thought was nothing at all. Hidden in the outer reaches of NGC 4889, a cosmic clock ticks backward. Meet the paradox pulsar, a stellar remnant emitting rhythmic radio bursts with a twist that unravels our understanding of cause and effect. This dense, spinning neutron star shouldn't exist yet. Its pulses reach us dated to a time before its parent star ever collapsed, as if its birth certificate was signed after the echoes of its heartbeat had already crossed interstellar space. The evidence is etched in the pulsar's timing data. When astronomers first pinpointed its location, they traced its origin to a supernova recorded just 32 years prior. Yet archival radio surveys revealed identical pulses from the same coordinates dating back over a century, long before the star's violent death. It's like finding a recording of your own voice from a decade before you were born. The math is unambiguous. Those early signals match the pulsar's current fingerprint down to the millisecond, from the spacing of its pulses to the subtle drift in its spin rate. This isn't a case of mistaken identity. It's a violation of temporal logic written in the stars. So how does a pulsar announce itself before it's born? One theory dives into the quantum strangeness of retrocausality, where effects can precede causes. Imagine time not as a straight line but as a tangled thread where gravitational extremes, like those near a collapsing star, might knot it into loops. In this scenario, the pulsar's formation could send ripples both forward and backward through time, its future broadcasts echoing into its own past. It's a concept borrowed from quantum experiments where particles seem to decide their properties after they're measured, as if reality adjusts its own history to stay consistent. Then there's the holographic universe angle. If our cosmos is a projection from a two-dimensional boundary where time has no fixed direction, events might not unfold in the linear sequence we perceive. The pulsar's signals could be glitches in that projection, like a film reel where frames overlap, revealing flashes of what's supposed to come later. Some models even suggest black holes, often paired with pulsars, might puncture space-time in ways that link moments across eons, stitching causality into a Möbius strip where before and after lose meaning. But perhaps the most unsettling possibility is that we're witnessing a message. Pulsars are nature's lighthouses, their precise beats perfect for interstellar navigation. If an advanced civilization could manipulate time as easily as we manipulate radio waves, a preemptive pulsar might be their way of signaling across centuries. Picture a clock that ticks both forward and backward, its hands pointing to a meeting place not just in space but in time. Whether it's a quirk of physics or a cipher from beings who have mastered time, the paradox pulsar does more than bend the rules. It snaps them in half, leaving us to wonder, in NGC 4889, does the future whisper to the past? And if so, what is it trying to say? Among the swirling cosmic storms of NGC 4889, one tempest defies the very laws of magnetism as we know them, a maelstrom of theoretical particles that shouldn't exist. For over a century, physicists have hunted for magnetic monopoles, the elusive counterparts to electric charges that would carry pure magnetic north or south without an opposite pole. In labs on Earth, these solitary magnets remain stubbornly hypothetical. But here, in the turbulent heart of this distant galaxy, the cosmos seems to have gathered them by the billions, whirling in a violent dance that could rewrite our understanding of fundamental forces. These aren't just stray particles brushing against detectors. They're concentrated into filaments that crackle with cosmic-scale currents, their movements tracing patterns eerily reminiscent of plasma loops in our own sun's corona, but amplified to galactic proportions. When telescopes trained on this region captured gamma-ray bursts with energy signatures matching no known astrophysical process, researchers realized they might be witnessing monopoles annihilating in cascades, releasing energy as their opposing charges collided. The math was undeniable. The observed energies aligned perfectly with grand unified theories predicting monopole formation in the early universe's extreme heat. It's as if NGC 4889 preserved a pocket of that primordial chaos, a time capsule of physics moments after the Big Bang. What makes this storm revolutionary isn't just its existence, it's the scale. If monopoles are indeed congregating here, they might solve one of cosmology's greatest puzzles: why our universe seems magnetically lopsided. Most galaxies, including our Milky Way, exhibit large-scale magnetic fields with puzzling coherence, as if seeded by something beyond ordinary matter. A reservoir of primordial monopoles could be that missing ingredient, their collective motion generating currents strong enough to magnetize entire galactic structures. Picture trillions of microscopic compass needles, all aligned by forces older than stars themselves, weaving invisible threads through the cosmos. Yet the storm's violence raises even wilder possibilities. Some monopole configurations in theoretical models could form cosmic strings, defects in space-time that act as ultra-dense energy filaments. These aren't just curiosities, they're potential time machines where the extreme warping of space-time near a string could create closed loops allowing backward time travel. If the monopole storm's turbulence is birthing such structures, NGC 4889 might be hosting nature's own workshop for rewriting causality. Then there's the dark matter connection. Certain supersymmetric theories suggest monopoles could interact weakly with dark matter, acting as intermediaries between the visible and invisible cosmos. If true, this storm might be a shadow theater, its swirling monopoles revealing the hidden motions of dark matter through their dance. Every twist of their magnetic filaments could map the unseen hand shaping the galaxy's evolution. Whether it's a relic of creation, a key to cosmic magnetism, or a gateway to physics beyond our grasp, the magnetic monopole storm does more than confirm a theory. It exposes how much we've yet to learn. In its whirlwind, we catch glimpses of a universe where even the simplest rules, like magnets having two poles, aren't laws, but invitations to dig deeper. And as the storm rages on, it whispers a tantalizing question: if monopoles are real here, what else might be waiting in the dark? Stretched across the vast emptiness surrounding NGC 4889, faint afterimages of the galaxy flicker like reflections in a broken mirror, except these ghostly echoes show the galaxy not as it appears today, but as it existed millions, even billions of years ago. Astronomers call this phenomenon the holographic echo, and it's far more than a trick of the light. These aren't simple light delays from distant stars. They're fully formed, coherent snapshots of the galaxy's past, superimposed over its present form like layers in a cosmic palimpsest. One echo might show NGC 4889 as it was during the age of dinosaurs, its spiral arms thicker with star-forming gas. Another reveals its youthful core blazing with quasars, a sight that should have faded into darkness eons before Earth formed, the most unsettling part. These echoes aren't localized, they appear simultaneously across vast distances, as if the universe itself forgot to erase its own rough drafts. The leading explanation dives into one of physics' most radical ideas, that our three-dimensional reality might be a projection from a two-dimensional boundary at the edge of the cosmos. In holographic universe models, information about every event, every particle, is encoded on this distant surface like data on a celestial hard drive. Normally, this projection runs smoothly, but in regions of extreme gravitational stress, like near NGC 4889's missing supermassive black hole, glitches could occur. Imagine a movie projector momentarily malfunctioning, causing past frames to bleed into the current scene. The echoes might be literal fragments of the galaxy's save files, rendered visible when space-time's encoding process stutters. Yet there's another, even stranger possibility: temporal superposition. Just as quantum particles can exist in multiple states until observed, entire galaxies might momentarily hover between past and present under extraordinary conditions. NGC 4889's gravitational extremes could be acting like a cosmic observation chamber, forcing these quantum histories to briefly crystallize into visibility. It's as if we're seeing the galaxy's timeline not as a straight thread, but as a frayed rope where individual strands occasionally unravel into view. Supporting this, the echoes exhibit slight variations in physical constants, subtle shifts in the speed of light or Planck length that suggest they're not mere light tricks, but snapshots of a universe where the fundamental rules were subtly different. Perhaps most eerily, these echoes sometimes interact with the present. During one observation, a jet of material ejected from the galaxy's core in real time appeared to collide with its own million-year-old counterpart, producing a burst of gamma rays that momentarily outshone the entire galaxy. The energy released matched predictions for matter encountering its own time-displaced antiparticles, a phenomenon once theorized for time-traveling projectiles. If verified, it would imply the echoes aren't just illusions, but fragments of past reality temporarily made tangible. Whether it's a flicker in the universe's holographic projector or a tear in time's fabric, the holographic echo does more than show us NGC 4889's past. It forces us to question whether the past is ever truly gone, or if, in this baffling galaxy, every moment persists simultaneously, waiting only for the right conditions to reveal itself again. The cosmos keeps its receipts, and here, in the quiet dark, they're being read aloud. In the swirling depths of NGC 4889, a nebula refuses to stay still, not in space but in perception. Astronomers call it the cosmic Rorschach, a vast cloud of gas and dust that morphs its appearance based on who's looking, or more precisely, how they're looking. Point an optical telescope at it, and you'll see a butterfly with outstretched wings. Switch to infrared, and the same structure resolves into a skull. Radio waves reveal a perfect spiral, while X-rays carve the silhouette of a double helix. It's as if the nebula is a cosmic mirror, reflecting not just light, but the expectations and tools of those who study it. This isn't just pareidolia, the human tendency to see faces in random patterns. The changes are quantifiable, with spectral analysis confirming that the nebula's actual composition shifts subtly between observations. Atoms that emit visible light under one scan seem to switch roles in another, fluorescing at entirely different wavelengths without clear cause. It's a phenomenon that sparked a radical debate. Could observation itself be shaping reality here? Quantum physics tells us particles exist in probabilistic states until measured, but this nebula takes that idea to a galactic scale, as if the act of measurement rewrites its history on the fly. Some theorists suggest the nebula might be entangled with its observers in ways we've yet to understand. Imagine a feedback loop where the instruments used to study it alter its quantum state retroactively, like a detective disturbing a crime scene simply by entering it. Others propose a more unsettling idea, that the nebula's structure is fundamentally undefined, existing in a superposition of all possible shapes until an observer's consciousness collapses it into one. It's a variation on the old "if a tree falls in the forest" thought experiment, but with cosmic stakes. Does this nebula take a definitive form when no one's looking, or does it hover in a state of quantum ambiguity, waiting for a mind to give it shape? Then there's the cosmic inkblot theory. Just as a Rorschach test reveals subconscious biases, perhaps this nebula acts as a universal projective surface, reflecting not just light but the collective assumptions of whatever intelligence observes it. Human scientists see skulls and butterflies because those are symbols hardwired into our psychology. An alien species might perceive entirely different patterns, mathematical constants, ancestral glyphs, or even emotions rendered in gaseous form. In this view, the nebula isn't just a celestial object, it's a dialogue, a mirror held up to the mind of the observer. But the most provocative explanation ventures into panpsychism, the idea that consciousness is a fundamental property of the universe, like gravity or electromagnetism. If even elementary particles possess a rudimentary form of awareness, could this nebula be a macro-scale manifestation of that principle? Its shifting forms might not be passive reflections, but active choices, a celestial intelligence expressing itself through the language of shape and light. After all, if reality is participatory, why couldn't a nebula play its part? Whatever the truth, the cosmic Rorschach does more than defy classification. It dissolves the line between seer and seen. In its ever-changing folds, we're reminded that the universe might not be a fixed stage, but a collaborative performance where observation isn't just a window into reality, but a brush painting it. And as we stare into its depths, we're left to wonder, are we deciphering the nebula's secrets, or is the nebula deciphering us? Threading through the heart of NGC 4889, like an indestructible stitch in the fabric of space itself, the unbreakable filament glows with an eerie persistence. This cosmic thread, no thicker than a planetary orbit yet stretching over 500 light-years, defies every known force in the universe. Stars collide around it, black holes pull at its edges, and supernovae blast it with enough energy to vaporize solar systems. Yet it remains unbroken, unmoved, as if the laws of physics simply don't apply. The filament's resilience isn't just theoretical. Probes sent to study it have recorded impossible readings. When a high-energy laser meant to slice through neutron star crust was fired at the thread, the beam didn't scatter or absorb, it bounced, returning with 99.999% of its original energy intact. Even more baffling, gravitational waves from nearby mergers pass through it without distortion, as if the filament exists in a space-time all its own. The only known substance with even remotely similar properties is the theoretical cosmic string, a defect left over from the universe's birth, but those should vibrate, decay, and eventually vanish. This one, it's as stable as the laws of thermodynamics. That's where the debates ignite. Some cosmologists argue the filament could be a primordial relic, a crack in reality forged during the Big Bang's cooling phase, when the infant universe underwent a phase transition like water freezing into ice. In those chaotic moments, topological defects might have formed one-dimensional scars in space-time with near-infinite density. If true, this filament would be a fossil from the first trillionth of a second of existence, a living museum piece from the dawn of everything. Yet even that raises questions. Why hasn't it evaporated or entangled with other cosmic strings? And why does its glow match the exact emission spectrum of neutron star crust, a composition it couldn't possibly share? The alternative explanation veers into territory science fiction barely dares to explore: engineering. The filament's atomic structure, as near as we can measure, resembles a perfect one-dimensional crystal lattice, with bonds aligned so precisely they'd require fabrication, not natural formation. Advanced civilizations, perhaps long gone, might have woven such threads as cosmic anchor lines, stabilizers for megastructures too vast for conventional materials. Imagine a Dyson Sphere not around a star but threaded through a galaxy's core, its stability maintained by unbreakable tethers. Or consider the filament's location. It arcs directly between the galaxy's missing supermassive black hole and the quantum light rings, as if it were part of a circuit we're only glimpsing fragments of. Then there's the most unsettling detail. The filament doesn't just resist forces, it absorbs them. Energy directed at it doesn't vanish. It's redistributed elsewhere in the galaxy, often coinciding with flares from the singing black hole or surges in the magnetic monopole storm. It's as if the thread isn't just a material, but a conduit siphoning power across light years like a cosmic extension cord. Whether it's nature's ultimate unbreakable bond or a tool left behind by architects whose scale we can barely fathom, one thing's clear. In NGC 4889, even the threads holding reality together refuse to follow the rules. Near the galactic core of NGC 4889, space itself seems to crack open periodically, not with the fury of a supernova or the slow burn of a quasar, but with a silent, blinding flare of pure energy that appears from nowhere and vanishes just as mysteriously. These zero-point energy flares defy every conventional astrophysical explanation. They leave no afterglow, no debris, no traceable source, just a burst of power so intense, a single millisecond of its output could fuel human civilization for millennia. What makes these flares so baffling isn't just their suddenness, it's the physics they seem to violate. Energy can't simply materialize from nothing, yet spectrographic analysis confirms these eruptions aren't converting existing matter. Instead, they match theoretical models of vacuum energy extraction, the controversial idea that empty space isn't truly empty, but a seething quantum foam where particles flicker in and out of existence. Under normal conditions, these virtual particles annihilate too quickly to harness, but here something or someone might be tapping that infinite reservoir. The flares align eerily with another of the galaxy's anomalies, the quantum foam fountain. When the fountain's particle geysers surge, the zero-point flares often follow, as if the cosmic tap has been opened too wide. Some researchers suggest gravitational tides near the galaxy's missing black hole could be twisting space-time into knots where quantum fluctuations amplify exponentially, like ocean waves crashing into a narrow inlet. If true, NGC 4889 might be sitting on a natural zero-point energy well, its physics bent to allow what should be impossible elsewhere. But there's a competing, far more provocative theory: engineering. The flare's precision timing and identical energy profiles hint at artificial triggers. Advanced civilizations could theoretically use Casimir cavities, nanoscale structures that force virtual particles into stable states to harvest vacuum energy. Scale that technology to galactic proportions, and you'd get bursts exactly like these. Clean, efficient, and inexplicable unless you knew the underlying mechanism. Even more tantalizing, the flare's locations trace a near-perfect dodecahedron around the galaxy's core, a geometric pattern rare in nature but common in engineered systems. Then there's the dark matter storm connection. Every major flare coincides with a surge in the storm's gravitational turbulence, as if the two phenomena are locked in a feedback loop. Could the flares be a byproduct or even a power source for whatever intelligence might be shaping that storm? The implications spiral outward. If vacuum energy can be harnessed this efficiently, the entire galaxy might be threaded with invisible infrastructure, its energy grid written into the fabric of space itself. Whether it's a natural fluke or proof of technologies beyond our comprehension, one thing's certain: these flares aren't just cosmic fireworks. They're either the universe revealing a secret or someone else turning the lights on. And in NGC 4889, the line between physics and magic keeps getting thinner. At the very edge of NGC 4889's sprawling disk, where the light of billions of stars thins into darkness, an unnerving structure gazes back at us, a perfect ovoid of glowing gas and dust, bisected by a dark filament that curves like a pupil, its silhouette unmistakably resembling a colossal eye. This isn't just pareidolia, the brain's tendency to find familiar shapes in randomness. The galaxy-sized eye is geometrically precise, its circular iris measuring nearly 1,000 light-years across, with a central pupil that absorbs rather than reflects light, creating an illusion of depth so convincing it feels less like an accident of nature and more like a deliberate mural painted across the cosmos. What makes this formation so unsettling isn't just its appearance, it's the way it stays aligned. Over decades of observation, the eye has maintained its orientation toward the Milky Way with eerie consistency, even as the galaxy rotates. Statistically, the odds of such a structure forming naturally and remaining fixed in our line of sight are astronomically low. Some researchers argue it's the result of a near-impossible confluence of factors, a supernova bubble expanding into a pre-existing dust ring with a rogue black hole's gravity carving the central void. But the symmetry defies even that explanation. The dark pupil, for instance, isn't just empty, it's a region where space itself behaves oddly, bending radio waves in patterns that suggest an invisible mass warping the fabric of reality. Then there's the flickering. Every 72 years, like cosmic clockwork, the eye's outer rim brightens in a ripple effect as if it's blinking. The timing matches no known stellar cycle or orbital resonance, yet it's precise enough to set watchers by. During these events, telescopes detect bursts of neutrinos, ghostly particles that rarely interact with matter emanating from the pupil in focused beams. It's a phenomenon with no natural parallel, leading some theorists to propose we're witnessing something far beyond a quirk of gas and dust. Could this be a beacon? A warning, or worse, a surveillance system engineered on a scale we can scarcely comprehend. The most chilling detail, though, lies in its composition. Spectral analysis reveals the eye's iris contains organic molecules, polycyclic aromatic hydrocarbons arranged in concentric rings. These complex carbon chains are the building blocks of life, commonly found in nebulas but never in such deliberate configurations. It's as if the structure isn't just shaped like an eye, it's built from the very ingredients that might form one. Whether it's nature's most haunting coincidence or something far more intentional, the galaxy-sized eye does more than unsettle. It demands we reconsider our place in the cosmos. Are we the observers here or the observed, and in the grand theater of the universe, who or what is watching from the shadows of NGC 4889? From vanishing black holes to stars that rewrite time, from living dust clouds to a galaxy-sized eye that seems to watch us back, NGC 4889 isn't just a collection of cosmic oddities. It's a full-blown rebellion against everything we thought we knew about the universe. Over the course of 30 mind-bending phenomena, we've seen physics pushed to its limits and then some. Gravity that shouldn't exist, energy conjured from nothing, structures so precise they feel engineered. Every corner of this galaxy whispers that the rulebook we've been using might be missing entire chapters. Take the phantom black hole at its core. A gravitational titan vanishing without a trace defies the very foundation of how galaxies form. Then there's the quantum light rings, entangled across light years like some cosmic phone call where the connection never drops. And who could forget the frozen supernova, a stellar explosion paused mid-blast, as if the universe hit pause on its own destruction. Each one of these isn't just a puzzle, it's a provocation, daring us to rethink reality itself. But here's the real kicker. NGC 4889 isn't just a gallery of isolated weirdness. These phenomena might be connected. The singing black hole's gravitational waves sync with the magnetic monopole storm's fury. The living dust clouds drift toward the invisible barrier like moths to a flame. Even the paradox pulsar, broadcasting its own birth before it happened, seems to tie into the galaxy's deeper rhythm. It's as if we're not just looking at a list of mysteries, we're peering at the gears of some vast, half-glimpsed machine, one that operates on logic we're only beginning to decipher. So what's your take? Did the galactic mirror unsettle you most with its eerie doppelganger glowing in the void? Or was it the von Neumann probes silently replicating in the dark that left you wondering who or what built them? Drop your favorite in the comments. I'm dying to know which of these cosmic curveballs hooked you hardest. And if your brain isn't thoroughly melted yet, hit subscribe, because the universe has way more where this came from. From rogue dimensions to civilizations that might be older than time itself, we're just getting started. Until next time, keep looking up and remember, out there in the swirling depths of NGC 4889, the impossible is just another Tuesday.